Okay, a ball is thrown vertically upwards with an initial speed of 8 meters per second from the roof of a building. The height of the building is 50 meters. Okay, 1. Does the velocity of the ball increase, decrease, or stay constant when traveling upwards? Explain your answers. Well, when the ball is being thrown upward, it is under the influence of gravitational acceleration downward. So which means the ball will experience deceleration, and hence its velocity as it moves up will be decreasing. Velocity of the ball decreases as it travels upward. Okay, part 2, calculate the speed of the ball just before it hits the ground. Okay, we have to be very careful here because the ball actually starts not from the ground but some 50 meters from the roof of a building. So let's draw the situation first. Okay, so the ball starts with V0 from the top of a building, and V0 is 8 meters per second, and going up and come down and hits the ground. So that is V final. Okay, we must realize that without air friction, when an object is thrown with some initial velocity, it will go up and come back to the same point with the same velocity. So therefore, this ball is being thrown up with initial velocity 8 meters per second. So therefore, it will come back to the same height with the same velocity, 8 meters per second. And then the ball will continue to accelerate downward due to gravity until it hits the ground with some velocity v. So therefore we can make use of the normal linear equation of motion. That is v equal u plus at. So therefore v is the final velocity, u is the initial velocity, the downward initial velocity, which is from the top of the building, which is equal to v0, and acceleration is again in the same direction of velocity, so it has to be plus g and multiply by t. Okay, but wait a minute, with this equation we do not have information about the time t. There is another equation that does not involve t, that is v squared is equal to u squared plus 2 acceleration and distance time s. So in our case, v squared is equal to v0 squared plus 2gs, which is v squared equal v0 squared plus 2gs, and v0 is 8 meters per second, g is 9.8, and s is the distance downward from the top of the building, which is 50 meters. So therefore v we get square root of 1045, that's 32.3 meters per second. So the velocity or the speed of the ball just before it hits the ground is 32.3 meters per second.